Hi everyone. This week I would like to walk through an example of a problem from the quantitative section of the GMAT. The problem that I've chosen to walk through is from the Official Guide for GMAT Review 2017. This is a textbook from a previous version of our class, but everything you need to know is included in this presentation. And the question is number 179, and it can be found on page 176 of this book. This question is a quantitative question, and it states, it would take one machine 4 hours to complete a large production order and another machine 3 hours to complete the same order. How many hours would it take both machines working simultaneously at their respective constant rates to complete the order? So for this problem, I took a slightly different approach than what the textbook took. Now, I guess I wouldn't say it's a different approach, but it's written out a little more thoroughly, so it maybe might help explain how the textbook authors arrived at their answer. So to go through the process I typically go through, the first thing I want to do is identify what do we know. I actually set an hourly rate of machine X. I identified it as R subscript X, and that's equal to 1/4 because machine X can complete 1/4 of a job in 1 hour. Then I set the hourly rate of machine Y, which is R subscript Y, as 1/3, and that's because machine Y can complete 1/3 of a project in 1 hour. Again, let's just review what are we trying to find out so that we know we're solving for the right thing. And we're being asked how many hours would it take both machines working simultaneously at their respective constant rates to complete the order. Normally at this point I would draw some sort of a picture. I'm a very visual person, and I find that a picture helps me to really get clear in my mind what I'm looking at, what I'm thinking about, what I'm trying to find out. But in this case, there's really no picture that will work. So for this problem, I just skip over that step. So at this point, I went ahead and wrote out my equation. So I set my equation as the hourly rate of machine X times the number of hours plus the hourly rate of machine Y times the number of hours equals 1. I set my equation equal to 1 because we want to know the time to complete one whole job. So when we substitute in our hourly rates for our machines X and Y, we get 1/4 H plus 1/3 H equals 1. Now we can go ahead and solve our equation. There's our equation again. We need to find the least common denominator, which is 12, so we're going to multiply 1/4 times 3/3 and 1/3 times 4/4, which will get us to our common denominator of 12. Once we do that, we come up with 3/12 H plus 4/12 H equals 1. We add those together, and we get 7/12 H equals 1. Now we need to multiply both sides by 12/7, and that's so that we can get the H isolated on the left side of the equation. When we do that, we get H equals 12/7. And when we make that a mixed number instead of an improper fraction, we get H equals 1 5/7. So if you look through your answer choices to answer the question, which is how many hours would it take both machines working simultaneously at their respective constant rates to complete the order, when you look through your answer choices, you'll see that 1 5/7 is answer choice C. If you had left it in the form of 12/7, you wouldn't have seen your answer here. And that's why it's a good idea to always read through the answer choices before you solve the problem. So if you had read through the answer choices, you would know, oh, I need to get to a mixed number. And that would let you know, save you just even a couple seconds of time from looking through for 12/7, seeing it's not there, then having to do the calculation, then look through the answers again. So it just saves you a couple seconds if you know the form you want your answer in right off the bat. If you have any questions about this or any other problems, email them to me, or post them in our classroom and let me know. Thanks.